Good morning, everyone. Thank you for coming to our final press conference, or AGU24. This is an update from the Perseverance View from the Top. First results from the Summit of Jezero Crater. With us today, Lindsay Hayes, Ken Farley, Candice Bedford, and Justin Mackey are going to give you some introductory information, and then we'll take Q&A from the room here in Washington and online. Those of you who have been here know the drill. Raise your hand. If you have a question, we'll bring you the mic. Please introduce yourself. If you're online, put your questions into the Q&A box. Please also identify yourself. Thank you, and we'll get started with Lindsay.
Thank you very much. I think too far. That's me. Hi, my name is Lindsay Hayes. I'm at NASA headquarters, where I'm the senior scientist for Mars exploration. In that role, of course, I represent both the Mars exploration program and the Mars sample return program, to which Perseverance is a really important mission for both of those, right? Perseverance, of course, with its fantastic capabilities, its wonderful instrumentation, is collecting all kinds of fantastic in situ data to be returned and analyzed later, as well as it's the first step in the Mars sample return campaign. Today, of course, from its new vantage point on the crater rim, there's some exciting new results. And so I will not delay any further and just pass it on to Ken Farley to say more.
Hey, good morning, everybody. Thanks for coming. I'm Ken Farley. I am project scientist for the Mars 2020 mission.
There we go.
Good?
To you.
Yeah. Almost 4 years ago, Perseverance landed here in Jezero Crater at the base of the delta. And we promised to explore the rocks that filled Jezero Crater and to eventually climb the crater rim to study what lies beyond. Given all of the uncertainty and the complexity of getting the rover across such a large landscape, I considered this a pretty bold and maybe even aspirational goal. But I'm happy to say that remarkably, yesterday, Perseverance made it to the end of this vision, crossing through the pass and starting down the outer part of the rim. I'm going to start by telling you a little bit about what has happened while we were exploring the interior of the crater, and then in the following speakers will talk about what we hope to do when we get outside the rim. This animation shows about the 18-mile journey that Perseverance has taken. It's a really spectacular journey. And each green dot that you'll see is a sample that was collected for the possible return to Earth by the Mars sample return campaign that Lindsay mentioned. So we started out on the crater floor, on the flat area in front of the delta, and we discovered that those rocks were igneous rocks crystallized from a magma. We then ascended up onto the delta, where we explored a complete sedimentary system that recorded the formation of a lake, the growth of that lake, and then the desiccation of that lake. The entire history is recorded in the rocks that we investigated. Then we passed through a series of enigmatic rocks that were very heavily altered by water, probably in the subsurface, groundwater in the subsurface. And most recently, Perseverance explored the inlet channel and discovered rocks with fascinating characteristics, potentially important for the mission's search for evidence that Mars might once have held life. But there's actually more, and that was the original idea for this mission, that we would explore inside the crater, and then we would explore rocks that are very different outside the crater. So in October, Perseverance began the ascent of the inner crater rim, and you hear some of the details of that traverse from the following speakers. But I want to start off by saying this is a really exciting geologic transition from rocks that filled the crater, and probably date to about 3.7 billion years ago, to rocks that existed before the Jezero impact and were uplifted to form the rim. And what that means is that the rocks that we are now exploring are likely older than 4 billion years. The age of the solar system is about 4.5 billion years. So these are amongst the oldest rocks in the solar system, and they're older than any rocks that exist on Earth. And from my personal perspective, this is really one of the most exciting things that this mission is going to do, is to be looking at rocks that were formed so early in the history of the solar system, almost the dawn of the solar system. And in that time period, there are many important and poorly understood processes that we hope to investigate. And they are processes that are poorly understood, at least in part, because the Earth essentially has no rock record from that time period. So if we're ever to understand how rocky planets behave in that first, say, 500 million years, can't do it from Earth, Mars is a very good place to try to do it. I'm going to show you a little bit about what we found when we did this ascent up to the crater rim. The crest of the rim, the pass, is at this place called Lookout Hill. And I'm going to show you a pan through an image from this area called Pico Turquino, the Pico Turquino Hills. So these are the rocks of the Pico Turquino Hills. And I'll pan through this mosaic. It's a series of small hills. And what we found in these relatively small outcrops is that the rocks are extremely diverse. And it appears that each one of the hills that make up the Pico Turquino Hills have a distinct assemblage of largely igneous minerals with some alteration by water. These are likely pieces of the earliest crust of Mars. And we also came across something quite surprising, which the pan is going to zoom in on here. And what you're looking at here is a field of brilliant white cantaloupe-sized cobbles. And the instruments aboard the rover confirm that these cobbles are pure quartz. This has never been seen by a rover before, and is potentially important because quartz forms from the circulation of hot water through rocks in a setting like a hot spring. So this is a potentially habitable environment that's totally different from the habitable environments that Perseverance investigated on the crater floor. Now, this particular set of rocks was too small for us to do really detailed work with the rover, but it's an important target as we investigate the crater rim further. And I'll just conclude with this image from the pass. So we just got this image yesterday. It is obtained with the NavCam camera, the relatively low-resolution camera that we use to navigate the rover. There will be additional high-resolution images looking off in the distance coming down in the next few days. But what you're looking at here off in the distance is the area we call Nili Planum. And some of those hills in the background are as far away as 60 kilometers. So this is our first look at this area of really ancient rocks that Perseverance will explore next. So the rocks that I have shown you are a foretaste of what we'll be investigating next on the far side of the rim. And to tell you more, I turn it over to Candace Bedford.
Yeah, hi everyone. Ooh, let's bring this closer. All right, cool. I'm Candace Bedford. I'm a research scientist at Purdue, and I'm a collaborator on the science team. So I'm going to walk you through, as Ken said, our future plans for this traverse and for exploring this really ancient material in the crater rim and beyond. So starting the animation. Yeah, so Perseverance has just reached Lookout Hill. This is the area that Ken was describing, some of the discoveries that we've been seeing. And our next stop is going to be a place called Witch Hazel Hill. Then we're going to go down the crater to outside of the crater, setting foot for the first time outside of this crater that we've been exploring since the start of the mission, to Lac des Champs, before returning back to the crater rim and exploring an area called Singing Canyon. This whole traverse is around 9 kilometers long, so just under 6 miles, and we have about 234 meters of elevation difference from the highest point to the lowest point. So we're going to be going down a lot and going up a lot. But here is the view of Witch Hazel Hill. So the reason we're really interested and excited to explore this area is because you can see there's a lot of layering exposed in the outcrop here. So this is a bird's eye view looking to the west. And this section of layered rock is really, really thick. So here we're panning around to the sides. I can show you, one, how steep and how kind of tricky this traverse down is going to be. And also, two, just like how extensive that section of layering extends to. So as geologists, we love layered outcrops. For us, every layer preserved is like, as we look down through that, it's like turning a book in the page of Martian history as we go through. So we're going to spend a lot of time exploring this bit by bit. About 6 months we're going to be here, making sure that we get all the information we can. As Ken said, there's also been some uplifting here. So there's likely going to be some information about impact processes and how that affects the rocks that we're seeing. So next in the traverse, we're going to be going out to Lac des Champs. So crossing some ridges. Maybe we'll see some more evidence of hot water fluids circulating through the rock in this area. And Lac des Champs, so we're really interested in this. This is far from the crater, and the rocks preserved here are actually representative of the rocks that we see in the region. So when we shouldn't be seeing any influence of the same impact overprinting as we might see in the rocks at Witch Hazel Hill. Here we're going to really be able to get stuck into the rocks that have implications for the whole region. And yeah, we have a few different traverse options. So to look around this ridge, and this is just another view of the ridge. The section here isn't as thick as the section as we're going to be looking at Witch Hazel Hill. It's tens of meters instead of hundreds of meters thick, but it's still going to provide a lot of amazing information about the geological history of this area. After this, we're going to move about 3 kilometers towards Singing Canyon, as I mentioned. Now, Singing Canyon is a little bit different to what we've seen at Witch Hazel Hill. In terms of when we look at it, and you can see here in this animation, we're going to be approaching Singing Canyon. We don't see that same layering. Here, instead, we have kind of a blocky appearance to the rim itself. Now, these blocks are from an impact that occurred before Jezero even formed that was pretty cataclysmic for Mars and threw out huge bits of the Martian crust. And so these are some of the representative of some of the oldest rocks that we're going to be able to investigate, over 3.9 billion years old. And there are going to be some nice windows into time to this period that, as Ken said, we haven't really investigated or know too much about. So yeah, with that, this is our future traverse plans, and I'll pass it on to Justin.
Okay, thanks, Candice. I'm Justin Mackey. I'm the Mars 2020 imaging scientist and the deputy PI for the Mastcam-Z instrument. I'm going to talk a little bit about the ascent up the crater rim and some of the great views that we've received from our imaging systems on the rover. And as you heard from Ken earlier, we've spent the last few months working our way up the crater rim, and then this plot here actually shows the progress. On the x-axis is the sol number of the mission, and then on the y-axis is the altitude, relative altitude. And you can see in the last 2 or 3 months of the mission, we've traversed vertically more distance than the entire previous 3 years combined. So it's been a new environment for us, and I'm going to share some of the great views that we've received from the cameras as we've crested the crater rim that Ken talked about earlier. So the next slide just shows an example of the kinds of terrain that the rover has been working its way through. The panel on the left shows some relatively featureless terrain, which has provided a little bit of a challenge for some of the visual auto-navigation algorithms. The terrain is also sloped. The terrain on the left is about an 8-degree slope, which isn't too bad. But the one on the right is a little higher. It's about 16 degrees. It's a little rockier, and this is an actual playback of telemetry that we received on Sol 1301. So that's been a challenge for some of the drivers, the rover drivers, but they've answered the call, and they've gotten us to the crater rim, as Candice and Ken have mentioned just yesterday. Along the way, though, we have managed to do some stops, and this slide shows an example of one of the stops along the route. I'm going to go to this animation where the rover came in. You can see it coming around the bend there, and hopefully the animation will start. Do I need to press it again? Let's see. Okay, one more. There we go. So the rover came around, and you can see it veered to the right, basically went to the west, pulled in near Pico Trquino, did an abrasion. You can see the bright abrasion spot there on the left. So we did a little bit of an investigation, then we took this spectacular 360-degree panorama. So we've been doing that as we've been working our way up the crater rim. We've also, in this particular spot on Sol 1282, we had a really great view into the crater rim itself, and there's some annotations here, and I'll start the animation. You can see that's over toward Neretva Vallis, where we came up onto the crater rim. And as we pan across, you can see various areas that we've investigated. The entire mission, you can see Ingenuity there, the resting spot of Ingenuity. The entire mission here is visible from this point. And so this was a great retrospective view into the crater floor, sort of capturing the entire mission in one vista here. And if we keep going here, you can see, as we approach to the right, you can even see the landing site here. These are all places that we visited. The Three Forks Depot there. And then Kodiak here on the going by. Kodiak shows up in a lot of our images. We hadn't seen it for a while, and so it's good to see it from this view. So this was a great chance for us just to sort of assess where we've been, a great view of the progress that we've made over the 33 kilometers that we've driven so far. This next slide, Ken talked about this. This just arrived yesterday, and it's looking to the north, and it's a great picture because on the right side is the interior of the crater, where we just came from, and on the left side is the exterior of the crater. So it's just a great shot. This is taken from the point we call Lookout Hill. You can see for a reason. I really like this picture because it really shows the transition from being in the crater for the last 3.5 years, and looking forward to the campaign ahead on the exterior. And then finally, I just included this shot. We've seen a lot of these pictures over the last several months where we look back, we see our tracks. You can see a little bit of slipping going on there. This is a nice time for us to sort of appreciate what we've seen, what we've done, and we're looking forward to the next phase of the mission. With that, I'll turn it back to Lindsay.
Thank you. So I just have one more, thing to sort of wrap up this animation. I think the Perseverance rover, of course, is just the latest in a history of exploration of the Mars surface that we have done, starting with tech demos like the Sojourner rover, moving through more and more complex missions and rovers. And as I said before, ultimately the whole point, one of the major goals, not the whole point, but one of the major goals of the Perseverance rover is to collect samples for ultimate return. So when we think about what it means to, evolve as a Martian and the evolution of a Martian and the changing vision of how we explore the surface of Mars, I think Perseverance, of course, is sort of a pivotal point as we're moving beyond to how we think about what a Martian is, and ultimately sometime in the future to human exploration of the surface as well. So with that, I believe, there we go, and I will hand it back to you, Lisa.
All right, thank you, panel. We're going to open it to questions, and Alex is ready.
Not surprised.
Thanks. Alex Woodsey with Nature. Are we going to go to Midway, or are we going to go back to Jezero to drop off, to be picked up?
Right now, the plan for what we're going to do with Mars sample return is currently under review. So right now, there's a lot of different things that we're considering. We have not, the plan, which included, of course, the industry studies, the review of those industry studies, that is all happening on schedule. There is a plan pretty soon to be briefing those to higher folks within the agency. And then ultimately how that, how all of that fits together with the whole campaign. We're hoping that we'll be able to have, some new plan moving forward early next year. And that includes, sort of what's happening with Perseverance. Of course, the science value of Perseverance as an in situ rover and the ability to collect samples is absolutely something that is important, but it is also the crucial step, in sort of thinking about how we get those samples back. And it has a role. It definitely has a role in getting those samples back as part of whatever architecture is decided. So I think we're in the process of deciding what that will be. I don't know if any of you guys want to say any more about the value of the science there.
Yeah, well, I'll just add something from the Perseverance perspective. The subtext of your question, just people didn't get it, is the ability for Perseverance to meet up with a potential Mars sample return mission. If Perseverance is going to do that, it needs to be a place that Perseverance can get to. It needs to be a place that MSR can get to. And there are trade-offs that are presently being considered for that as part of the architectural studies. But from the Perseverance perspective, we don't have to decide. There's nothing that's happening right now that forces our hand one way or another. We are likely to spend about the next 6 months investigating Witch Hazel Hill. And I think that is likely to be on the time frame on which at least there's at least some more clarity about where a potential rendezvous will happen. So we will just continue on to do the science that we've been doing all along, and we await whatever decision gets made about MSR.
What more questions from the room?
Hi, Nick Ogassa with Science News. I was wondering if you could talk a little bit more about the significance of the quartz cobbles that were found.
Yeah, so that field of quartz cobbles is very localized. It occurs in an area that's a few tens of meters across, strongly indicating that they were once in place in the rocks that have now eroded away and they've been left behind. This is a very common feature to find quartz laying on the surface because it's a very resistant material. And it's important because in systems where you have water circulating through rock, the rock partially dissolves, silica goes into solution, And then as that fluid cools or goes through chemical changes like changes in pH, the quartz can precipitate. And at least in some cases, that occurs at temperatures that are habitable. We don't know that about these particular cobbles, but it is it's a kind of a setting that we know that is inhabited on Earth. And so the goal of our future search for this is to find this rock in place so we understand how it fits into the rest of the rocks, and also in a place where the pieces are big enough so that the pieces are like I said, they're cantaloupe size, and neither our drill nor our abrader can actually operate on such a small rock. The rock would just move out of the way if we try to work on it.
We have one question online. Yes? No? Yes, good.
Hi, we have quite a few online questions. This one is from Leo Enright at Irish TV. He says, for Ken, just to clarify, these 4 billion-year-old rocks that you are now seeing, are they definitively the oldest rocks we have ever seen? Or have we seen similar rocks at the moon, for instance, or elsewhere at Mars landing sites?
Well, first, let me just point out that definitive for dating of materials on Mars is a tricky business. There is no definitive dates, and I probably should point out that we throw numbers around. They are our best estimates, but they are just estimates. This is one of the reasons why we want to do sample return. I don't think we actually know whether these are the oldest rocks that any rover has investigated. They could be 4.4 billion years old. We don't know. In that case, I think very likely they are the oldest rocks. Some of the blocks that Candice mentioned that may have been ejected by the Isidis impact, I think if that is what they turn out to be, they would very likely be the oldest rocks that a rover had investigated. But all of this is really predicated on a model for ages which we should have some skepticism about, at least until the samples come back and get dated.
Okay, great. This next question is from Richard Lovett. He's a freelancer. He asks, how much vertical distance did the rover climb en route to its present position? It looked like about 550 meters on the graph. And he also asks, what is the rover's overall health?
Okay, for that first question, that's right. It's it's a little over 500 meters. I'm not sure if we probably didn't update it based on that last drive, but you could see there, we're at negative 2,000 down to 2,500, maybe a little more, 2,550. So that is correct. And this is all relative to a reference level on Mars. It's sort of, you can think of it as a sea level average value. And the second question, what was the second question?
Rover health.
What's that? Rover health. I can answer that. The rover health has been very good. The rover's been performing nicely. We don't have any off-nominal behaviors. I did mention as we were working our way up the crater rim, there was a little slippage, autonav occasionally, we call it faulting out, but it basically sometimes can't get texture on those featureless terrains, but that's really nominal behavior, and it's been reacting nicely to that. Everything else, all the instruments are healthy and busy taking data, so everything's looking good.
Do we have any more questions in the room? People are busily typing, thinking.
Just to follow up on that rover health question, what are sort of the life-limiting factors? Like, what is the first thing that might likely go, even if it's not going to be for a while?
I'll take that one. You know, we track a lot of what we call consumables. These are things on the rover that could wear out with use. Certainly, we're keeping an eye on actuator usage. That's obviously something we really need to drive around. We're not near the limits of any of the actuators. They've all been tested to several times the mission length and mission lifetime. I would say actuators are probably the biggest item. The other thing that when you have a vehicle on the surface of another planet like Mars, it experiences temperature swings, the diurnal temperature swings, day in and day out. And that puts stress on the system because of the coefficient of thermal expansion and things tend to get a little smaller when they get cold and then get bigger in the morning. And so this diurnal cycle puts stress on just the vehicle in general, a lot of the parts and so on. But fortunately, the rover has a thermal management system that tends to keep that in check, and we don't experience the extreme swings. But there are some items on the rover, some of our cameras up on the mast, for example, or out on the end of the arm when the arm is out, they experience deeper thermal cycles. So those are other things that we keep an eye on and we track. But we're not seeing any degradation yet in any of the systems. So, and it's designed to withstand these, and those have been tested as well.
Question online.
This question is from Joel Achenbach at the Washington Post. He asks, how does the upcoming terrain compare in complexity/challenges/obstacles to the terrain on the inner side of the crater rim where the rover has traveled? Is this new terrain outside the crater rim or just the downslope of the outer crater rim?
I can speak a little bit to that. The area that Candice showed called Witch Hazel Hill is steep. I don't think it's any steeper than the inner rim, but the interesting difference is that the inner rim was almost all regolith. And in some places we slipped in the regolith, and some places the rover made great progress through it. The area in Witch Hazel Hill is different. It's rock outcrop. And of course, that's scientifically interesting, but presents potentially different kinds of challenges for the rover. It's potentially has some short wavelength variations, steep scarps that are potentially not traversable. But we spent a lot of time identifying areas where the terrain is very likely traversable. We know that we have identified a pathway where the orbital data suggests we can find a route through, and using that, we've also identified targets to investigate. So we'll see how that goes, but I don't think there's anything that is other than the fact that it is steep, there's nothing especially challenging there, steep and rocky.
Next question is from freelancer John Amos. He says, you were sent to Jezero to search for signs of past life. You have a number of sample tubes now in the rover's belly. If you could pick one tube, pop it in your pocket, and bring it home today, which one would have the greatest possibility of retraining biosignatures?
I'm just going to say, as the lead scientist for MSR program, I would advocate for more than one sample to be returned. I'm just going to start with that, but I will let you talk about your number one sample.
About 4 months ago, we described a sample from a location we call Chiava Falls, and it had some very interesting characteristics that I think make it, from the astrobiological perspective, the most promising to bring back. Had evidence of oxidation reduction gradients. It had evidence of organic matter. The details of those studies are working their way through the publication process. It should be out relatively soon. But from an astrobiological perspective, that would be number one. And my number two would be the salt-rich mudstone that we collected at the base of the delta. So these are, that's a rather different environment. We suspect that was being produced in a salty lake, whereas the Chiava Falls rock was likely deposited in a river setting. So those are my two top choices.
Yeah, I definitely agree with the Chiava Falls, and the other exciting part about that area is there's lots of evidence of different types of alteration that have occurred. So we know that there's been lots of fluids there, which is great for life. I think another one of my samples that I would probably pick is from the Martian unit as well. And on the east side of the Martian unit, we've seen a lot of evidence that there could have been some local reworking of material in a kind of like lake environment. And again, we know that there's been lots of different types of fluids circulating there too. So I think this is another kind of great area for looking for signs of life as well.
Yeah, and I echo both of those, and I will also advertise we have our sample return session tomorrow if you want to tune in and learn more about them, including images of all the samples if you want to pick your own favorite.
And that video is also available online, the sample collection.
Yeah, and you can also see that online as well.
We have one more online question. This one is also from John. He asks, with respect to the 500-meter difference in elevation between the crater floor and the rim, how important is that height change when considering the engineering challenge of landing on Mars to collect the samples? Lower elevations are easier to land on than higher elevations.
So, in the current architecture, the baseline architecture that is being reconsidered and is undergoing review right now, the baseline architecture does involve Perseverance returning into the crater for sample return. And so that would be sort of where that rendezvous is. This is certainly something that is part of that whole reconsideration that architecture is undergoing at this time. So yes, it is important, and yes, it is something that we are considering.
We have a question in the room.
I'll stop after this, I promise. It's easy for Justin, just that the steepness of this climb, is this like the steepest climb we've done anywhere on Mars? How does it compare? Is it like a superlative anything?
It's close. I think, gosh, I feel like I should know this. There's been a number of missions where we've done some pretty steep climbs. One of the ones I remember was on Mars Exploration Rover, where we went down into a crater. That was pretty steep. That approached 30 degrees. I don't think we've gotten to 30 degrees on the climb up here. We got up to 20 maybe. So I don't think it's the steepest ever, but it's certainly the longest. I mean, it's been going on for months, which is something we haven't done. On the other hand, MSL has been working its way up Mount Sharp for the last few years as well. So it's possible. I don't think they've gotten that steep.
We have a friendly competition going.
Yes. And we will mention that we just passed them in the all-time traverse distance. Not that anyone's counting.
Not the all-time traverse distance.
For the road.
Because opportunity still, I
Oh, you're
believe,
right.
holds
You're
holds
right.
the
Thank you
record.
for
So,
catching me. Yes.
Perseverance has just gotten into second.
It's not a competition.
This is me putting my Mars exploration program hat on. They're second place, so you're
Yep, thank you.
catching up quickly, but
Active mission.
exactly.
That's what I was
There you
thinking
go.
of.
Any more questions from the room? Online? No more online? Then we will thank our Perseverance team for talking with us today. Our last roundtable will be this afternoon at 1:30. It's kind of a grab bag from our USGS friends. They're going to talk about groundwater droughts and greenhouse gases on federal lands. And I think they also have something about, I'm forgetting, sorry to the USGS team, but come, it's going to be great. And now lunch is served in the press room. Thank you all for coming.